For section 6, today we're talking about arithmetic sequences, and the sequence is simply an ordered list of numbers, and each one of those numbers in that ordered list will have a common difference between the other terms. A little bit of notation, things to keep in mind here, is this subscripted numbers. A subscript number is a number that appears below and to the right of that variable. These represent position numbers. All right, so a subscript is a position number, and this position is going to refer to the position in the sequence. So for example, if I had the sequence 2, 4, 6, 8, 10, ... I would say the third position in this sequence is 6, right? The third term is 6. And that would be represented by this subscript number, and that would be a sub 3. All right, so those subscript just refer to position numbers in our sequence. All right, let's talk about our topic today, which is arithmetic sequences. An arithmetic sequence is a sequence that has a common difference or a constant difference between terms. And the example we just gave up above is an arithmetic sequence. It has a common difference of positive 2 between terms. In example 1, we want to write the next 3 terms of each arithmetic sequence. So there must be a common difference, and our job would be to figure that out. So we have -7, -14, -21, -28. It looks like our common difference is -7. We keep subtracting 7. So the next few terms would be -35, -42, and -49. In our next one, letter 1b, we have -12, +0, +12, +24. Our common difference here in between terms is a +12. We keep adding 12 to the previous term to generate the next term. So our next few terms would be 36, 48, and 60. All right, we can graph arithmetic sequences as well. Now there's a few things that we should notice when it comes to graphing arithmetic sequences. Along the y-axis is the value of the term. It's the output, or it's the sequence numbers. Along the x-axis is the position number. Okay, it's the first term in the sequence, the second term in the sequence, third and fourth. So here we have 1, 2, 3, 4, 5, and 6. All right, those are the position numbers. And then on the y-axis, remember, are the outputs, or the term values, or the sequence values. And here we'll go up by 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right, so my first term here, it looks like it's 4, so I go 1 over and 4 up. And then I would go 2 over, the second term is 8, 2 over and 8 up. And then 3 over and up to 12, there's my 12. And then 4 over and 16. So you can probably guess that fifth term number is going to be up here at 20. Now we don't have that listed, we don't have to plot that. We are good, and we are done graphing our arithmetic sequence when we plot those 4 points. All right, likewise, you would do the same thing over here on the right. Our first term, second term, third term, fourth, and fifth go along the x-axis. Okay, these are the term numbers or position numbers. And along the y-axis, you're going to have the value of those terms, or the outputs. Okay, here it looks like you're going to go down. Let's see here, we'll go up by 0.2, 0.4, 0.6, 0.8, and 1. So here our first term is 1, our second term is 0.8, our third term is 0.6, fourth is 0.4, and you can probably guess that the fifth term would be 0.2. But again, we're done after we plot those. Now, a couple of things you should notice here is that these are discrete graphs. They're not continuous. Okay, you do not connect these points with a straight line. And the reason why is because along the x-axis, remember, these are your position numbers. You only have 1, 2, 3, 4. You don't have the position of 3.5 or 2.5 or 1.75. So you only have these integer values as your x's. All right, so these are going to be discrete graphs. You should also see that there is no y-intercept. In other words, there is no value, right, no output with an input of 0. There is no 0 term. And you should also notice that these are linear. Right? All these dots are going to lie in a straight line here because they are arithmetic. They have a constant difference, and that constant difference is the slope. All right, let's jump down to example 3 now, and let's look at a few graphs and determine if they represent an arithmetic sequence. So based off of the things that we just set up above, they have to be linear, right? They have to have a constant difference. Then we can determine that it's arithmetic. If these things are not true, then it's not an arithmetic sequence. So let's take a look at our first one here in 1a. We see that the first term is 15, the second term is 12, the third term is 9, and the fourth term is 6. Notice that I'm just listing the y-coordinates. Those y-coordinates, remember, are the value of the term. So it looks like it's going down by 3 each time. It has a constant difference of -3. So here I'm going to say yes, this is a linear graph, and therefore it's an arithmetic sequence. All right, let's see if the same is true for 1b. Again, I'm going to list my y values. I have 2, then I have 4, 7, and 11. Well, it looks like I'm going to go up by +2, and then I'm going to go up by +3, and I'm going to go up by +4. So this is not linear. Right? It does not have a constant rate of change, and because it's not linear, it is therefore not an arithmetic sequence. All right, flipping the page over to the back side, we're going to take a look at writing a formula for the given arithmetic sequence. Now it's going to follow this little template here that says a sub n is equal to a sub 1, my first term, plus d, my constant difference, times n minus 1. So the two things that you need to know are the first term, and you need to know d, the constant difference. You can call it constant difference or common difference. Either way is fine. All right, so let's take a look here, and we got 55, and then down to 40, then down to 25, then down to 10. It looks like this is going down by subtracting 15 each time. And my first term, I can see right there at the beginning of my sequence, is 55. So to write my formula for this arithmetic sequence, I'm going to say a sub n. All right, that's kind of like saying y equals a sub n equals my first term, 55, plus my common difference, or my constant difference, which is -15 times n minus 1. All right, now I can leave it like this, or I can simplify some things by distributing this -15 in and combining some like terms. So let's take it one step further. We have a sub n is equal to 55. Now I'm going to distribute this -15 in. I get -15 n, and -15 times -1 is another +15. So here's my final sequence. A sub n is equal to 60. I combine my, 55 and 15 is not 60, it's 70. All right, Mr. Delora. There we go, 70 minus 15n. And there's my arithmetic sequence for this sequence up here. I should say this is my formula for my sequence up here. All right, let's try another example here. 1b, 8 to 16 to 24 to 32. It looks like my common difference, I'm going to start off by finding my common difference, is +8. My first term is also 8. All right, use your arithmetic sequence formula right here at the top, and go ahead and write your arithmetic sequence for, or sorry, I should say, write your formula for this sequence in 1b. All right, let's go on to example 5. Online bidding for geothermal heat pump increases by 25% dollars each bid after the $420 initial bid. Write a function that represents this arithmetic sequence. All right, so let's think about this sequence here. It's increasing by $25 for each bid after the $420 initial bid. So I'm just going to write that out. 420 is the initial one. In other words, that's the first position. Now it's going to increase by 25. So if I add 25 to that, that would be my common difference. Then my next one here would be 445. After 445, I'm going to add 25 more to that. I'm going to end up with 470, 495, and it's going to keep increasing from there. So let's write a function that represents this arithmetic sequence. I have my first term of 420, and I have my common difference of positive 25. So I will write a sub n is equal to 420 plus 25 times n minus 1. Now it's okay for us to leave it just like it is right here. We don't actually have to simplify it. Alright, take a few minutes, pause your video, and graph that function. And it says the winning bid was 1,520. How many bids were there? Okay, if the winning bid was 1,520. Well, that means we're going to substitute that 1,520 into our a sub n. Let's take a second to do that, and then we are going to solve for n. All right, so solving this equation, working backwards, we're going to subtract our 420, and that gives us 1520 minus 420 is 1100, or 1100, and that's equal to 25 times n minus 1. Next up, we now need to divide 25 off of here, divide the 25 over, and we end up with n minus 1 is equal to 44. Next, we're going to add the 1 over. We get n is equal to 45. So n, the winning bid, was the 45th bid, and that's the 45th position number in this sequence, was 1,520. So it was the 44th bid. All right, take a minute, pause the video now. Our video is going to end, and plot these data points here, this sequence. Make sure it's linear and discrete.